Hello students, welcome to the IMS Gate Academy. In the series of operating system like foundation series, let's continue another concept. I'll be starting here CP scheduling or process scheduling. From the last class, we have seen the process concepts, various process concepts, and followed by dispatcher. We understand various schedulers also. We understand, right? So now let's look into the CPU scheduling or process scheduling concept. So which is one of the most important topic from the process management. Let us understand what exactly the purpose of the CPU scheduling algorithm and various scheduling algorithms also we'll see. So look at the concept here. The situation, understand this here, we are going to talk CPU schedulings, right? CPU schedulings. What this CPU scheduling is talking about, understand clearly. Also known to be process scheduling. CPU scheduling is also known to be process scheduling. So we have seen the various process states like ready state, running state, wait state, right? New state like suspend state, like termination, various states. These various states are implemented with various queues implementation also seen, the various queues maintained by the operating system. The queuing diagram also we have seen, right? So particularly if you look at the ready queue, okay, what is the ready queues containing? This ready queue contains the PCBs PCB, process control block 1, PCB 2, PCB PCB 2 like this, n number of PCBs is so told. N number means based on the capacity of the ready queue. Now here is a running state, right? Here is a running state. Here is a running state. CPU, understand? CPU is ready. Now see. Also we have discussed the STS. What is STS? Short-term scheduler, right? Short-term scheduler. In a short-term scheduler, there is a worker like dispatcher. Okay. So dispatcher. We have discussed about dispatcher also. So dispatcher is the component of the short-term scheduler. Implementation of the short-term scheduler is nothing but CPU scheduling only. Please understand. Implementation. This is a concept. The concept of the short-term scheduler we observed, like just pick a process from the ready queue and assign to the CPU whenever CPU is ideal. This we have learned, correct or not? So this implementation, process of implementing this short-term scheduler is nothing but CPU scheduling or process scheduling. So what is the implementation task? Please understand. Now this short-term scheduler has to pick, dispatcher has to pick a process from ready queue and assign to who? What? Dispatcher, dispatch. So dispatch or allocate or schedule, understand. So dispatch a process from ready state to running state. So now this short-term scheduler, short-term scheduler implementation part, what? CPU scheduling, right? This CPU scheduling uses some criteria. Criteria for selection, for process selection. It uses some criteria for process selection. Very good afternoon, very good afternoon. So as per the schedule, just I want to continue this process concept, process management. Now this session will be focusing on CPU scheduling algorithm, so try to follow it. Okay, the CPU scheduling is nothing but implementation of short-term scheduler, and it uses some criteria, specific criteria for selecting or loading or selecting a PCB of a process from ready queue and assigned to the CPU state. The selection criteria is nothing but implementation. We have to look into various techniques, the various we understand the policies for selecting a process, because this ready queue has more than one process, right? Ready queue has more than one process. Whenever ready queue has more than one process, some selection criteria or your techniques or algorithm, you understand, you apply, pick a process and assign to the CPU. That's need to be done. So that's only activity of what? Short-term scheduler or CPU scheduling or process scheduling. I hope you understand the statement. Everyone, please respond. Yes. Applying some criterias, applying some decision policies to pick a process from ready queue and assign to the CPU whenever CPU is setting ideal. That's the activity of this one, correct. So some criteria will apply, we'll observe what criteria is going to be applied here. Okay. Clear? The statement is clear? Now understand. So selection criteria we are putting, right? Selection criteria is putting for selecting a process assigning, right? We need to keep some objectives for selecting the criteria, because decision policies, like it can be 1, 2, 3, there are 5 policies you are going to be designers on that. 5 policies you are going to be design, or 10 policies are going to be take, out of which is better, out of which is better, right? So we have to put some criteria. So now here I am writing CPU scheduling, the CPU CPU scheduling are like, understand objective of CPU scheduling. So I can write it like, objectives are also, we can tell the metrics for selection, objective or metrics of the CPU scheduling, CPU or process scheduling. I hope you understand what I am trying to say. So whenever ready is more than one process is there, ultimately whatever mechanism you are going to apply, some policy will apply, select one of them, out of one of them you have to select it and select and assign to the CPU. That's fine, that's clear. But the point is that, so whatever policy you apply, you have to keep some metrics, you have to measure some measuring keywords, measuring points or metrics objective, understand, that need to be kept for the selection criteria, decision making policies. So what are these objectives? The first objectives, please understand, please understand and please understand. So maximize the CPU utilization, please understand. Okay, CPU utilization meaning what? Usage of CPU. So selection criteria, whatever algorithm you are going to apply for selecting a process, those policies, those decision making policies, algorithms should not make CPUs ideal. So try to utilize the CPU as much as possible, means keep as much as busyness. Keeping the processor busy is nothing but improving the CPU utilization. So always try to utilize the processor, that need to be understand. Maximize the CPU utilization. Clear all of you? Second objective, maximize the throughput of the system. Throughput of the system. Maximize the throughput of the system. It also, please understand, not only increasing the number of process executed per unit of time, also try to minimize the times, waiting times try to minimize. So third objective or third matrix is minimize. So minimize the waiting time. Please understand, waiting time. So sometime process will wait in the system for resource or for processor, various reasons it will wait. Try to minimize the waiting time of a process in the system. Clear? Waiting time. So here that I can mark it, minimize the waiting time. Also minimize the turnaround time. Also minimize the turnaround time. TAT short form. So this I am writing short form, wait time. The third one, minimize the response time also. RT. Response time is what? RT. I hope you understand. These are the major objectives or criteria or metrics for applying the decision making policies. That's what CPU scheduling process, scheduling algorithms. Clear? Whatever you are going to apply the policies, so this should be like satisfy at least some of them, so that we can say there is a good algorithm, good decision making policy we can tell. One is improve the CPU utilization, increase the throughput, minimize these terms. Okay, I hope this is clear. Note of it. Now look at. So now the few things we'll understand. So this, like I said, maximize the CPU utilization, we understand. So keeping the processor as much possible, like keep it is busyness only. The second term I use a throughput. This throughput is a word you are going to use many places. Nothing but in the operating system use the term throughput. We use the third term when we study in computer architecture also. We also use this throughput term in computer networks also, like a throughput of a network. Are you getting a throughput of a network, throughput of a processor, throughput of a system, the various ways we use. So now tell me, what is this throughput tells? What is the meaning of throughput? Yes, everyone, kindly respond, give a comment. What is a throughput? Throughput means what? Please observe, all of you. Throughput is like nothing but, please understand. So number of processes or simply jobs, okay, jobs are completed or executed. Completed, simply I can say number of processes or jobs are completed their execution, completed their work, understand. So their execution per unit time. So unit time can be a 1 second, you can keep it 1 minute also, you can keep it even 1 hour also, can keep it even 1 millisecond also, can keep it. Number of process completed per unit of time. Very good. Suppose example, see, like throughput of me, if I want to calculate how many topics I completed per unit of time. Suppose one day if I plan a schedule of 5 hours, suppose let's say 10 hours I planned, let's say 1 hour. In 1 hour, how many topics I could able to complete with understanding of a student. This is the throughput of a faculty. Similarly, we can also measure throughput of a student. When a student is attempting the questions, some student they able to attempt the, like let's take 10 questions per 1 hour. Some student may solve 20 questions per hour, correct. Some student may solve only 5 questions per hour. That is their throughput of a that particular person, understand. So you have to define the domain. Like here we are understanding what the jobs completion, execution of a process, how many process completed per unit of time by the system, you understand. If I talk about the two nodes are connected by a link, if I say what is the throughput of this node A, means how many packets are transmitted by particular node per unit of time is the throughput of the particular node. I hope it is clear. In the memory system, if the 3 memory systems are connected hierarchical manner, suppose if I want to know what is the throughput of a system, what is the throughput of that memory system, 3-level memory hierarchy, that simple number of words are transferred per unit of time. How many words are transferred per second is the throughput of that memory system. Or especially if I talk about disk, magnetic disk is there. If the disk rate something is there, if I want to know what is the throughput of this disk, very simple, how many bytes the disk is able to transfer per unit of time. I hope the word is clear, the term is clear, throughput. Wherever throughput word you see, simply you see how much work being done per unit of time. It is measured the amount of work done per unit of time by the system or resource. It's simple. Is it clear, all of you? So this should be increase. Right. So next term I given. What is the next term I given here? The minimize the waiting time. So waiting time, please understand, in the system process may wait for resource, please understand, or process may wait for IO device, process may wait for another process, like this, understand. So try to minimize the waiting time. When you minimize the waiting time of a process, automatically throughput of a system will also increase, correct? Yes or no? Now the turnaround time and the response time, the 2 words are there. Turnaround time and response time, 2 words are there. Let us observe what is this turnaround time it is talking about. Turnaround time. Look this. I'll give you example to understand the turnaround time, all of you. Very simple. Suppose whenever the faculty just conducting any class, let's say the faculty schedule the class 9 o'clock in the morning, 9 to 5 assumption, 9 to 5 it has been scheduled. So 9 to 5 or 9 to 6 if I take, total how many hours would be there? 9 to 6 if I plan? 9 hours, right? 9 hours, 9 to 6, right? Yes sir, 9 to 6 plan. So general students comes 9 o'clock. The faculty also comes to 9 o'clock. Then he will teach, many discussions happens, question solving, concept discussion, all, and the class will end up at evening 6 o'clock, right? Evening 6. Total 9 hours is there. But if you see total 9 hours, but throughput will be less. Throughput will be not 9 hours. Throughput will be less. Why? Because when the class is scheduled 9 o'clock, students may not come 9 o'clock. May students comes 9:10, 9:15. Faculty may start 9:15, but schedule is 9 o'clock only. but faculty may give break, short break at 11 o'clock. Again he will give a break of 1 hour in the middle lunch. Then after that, after 2 hours he will give a break, and middle so much it's doubt discussion, normal talking. So many things will happen from 9 to 5 or not, 9 to 6, yes or no? Respond. Now turnaround time is 9 to 6 is a turnaround time. Starting time 9 o'clock, completion is 6 o'clock is a turnaround time, this one completely. But internally the efficiency of the class will be maybe 8 hours or even 7 hours, 7.5 hours only. Efficiency of the class or throughput of you understand here. So total 9 hours not being utilized by the faculty or student, because other things also will go. Now through turnaround time here is nothing but simply arrival time, time interval between arrival and completion. Can I say? Can I use this word? Observe now. Time interval. So time interval between arrival time is what? The time at which process arrive. Arrival time of a process and arrival time of process and completion time. Completion time of a process. I hope you understand. Or other way also we can define, simply like completion time of any particular process minus arrival time of a process. This is also meaning is same only, na? Both this only. Number of instructions completed per unit of time achieved by the pipeline. Very great. Yes, good, that the statement is correct. Okay. So turnaround time is clear. The time at which process started, it's completed. Like the time interval between from starting to ending. In between many things will happen. It's not only like only execution. Even waiting can also happen. Like so, the diagrammatical also so, but try to understand the term. So next I said what? Response time. Response time. Okay. Response time. See, we have to minimize the response time. We want to minimize the response time, nothing but system should be more responsive. If the system is more responsive, response time is less. That means what I am trying, the time at which its first request is submitted. The time at which its first request is submitted to the time at which its response, it starts responding. Okay, please. This time interval we call response time. Means very simple. If I take suppose example, you understand, this is my browser, web browser is there. In the web browser we have hyperlinks, right? The moment you click on this link, it start opening the new page or not? Yes or no? Yes or no, all of you? It start opening or not? Yes or no? Now see, the time at which I submitted my request to the time at which responded. Like suppose at 0 time I clicked and time at 2 it responded. Time at 2 responded. So now 2 minus 0 will be the response time. Whenever the response time is less, system is responding more. You observe like modern systems today, modern operating systems are more responsive, nothing but taking less response time. Earlier system, like suppose if you could have experience of using Windows 98 operating system, 95, 2000 XP, those systems are less responsive, means taking more response time. The moment you something you ask, start responding slowly. Best example I can give, like the Windows 98 operating system which I experienced. If you take a mouse pointer and click on the start button, it takes time to open that. And after that, if you select something in the program, you just click on, and it is used to take some time to get open the application. So it is taking more response time. Means system is responding less. I hope this is clear. Respond. Please respond. Suppose our response time should be minimum. The time at which if I put a question to the time at which response start generating from student, this is also response time. So I am expecting from the student response time should be less, so that you are more responding to me. I hope you understand now. So does it make sense? What is the response time between you and me? Isaki? See, that's what, like, I am waiting for your response. I am just expecting minimal response time. Are you there? Great, great. So this is the term response time, like turnaround time, waiting time should be minimal. This is the major objective of studying the various decision making policies. So what is implementation of short term scheduler is only nothing but the studying of process scheduling or CPU scheduling, correct? And that we are putting some objective or metrics to that scheduling policies. So those should be and accept this thing, like maximizing the CPU utilization, throughput, minimizing time. Whichever algorithms are going to be satisfied this our requirement, then we can declare this would be the suitable for implementation. Also it will vary from the flat, like environment, application to application. So further we can discuss. Clear? Okay. Now look at the understand. Now we are going to see the various policies. Just before addressing into various decision making policies to pick a process from ready queue and assign to the CPU. So let's understand, like some, apart from this, process also maintains some process times, the various process times which we use during this scheduling policies, process times. So let us familiar with this process times. So now next 2-3 slide, 1-2 slide, you understand whatever the process time I am going to discuss. If you are good at this, if you understand this thing, problem solving becomes very easy. From scheduling algorithms, from CPU scheduling, definitely we can expect one question from GATE exam point of view. You go and see the previous year, you will find a question from the CPU scheduling algorithm that is minimum 2 marks, sometimes 3 marks also comes. But compulsory one question would be there, either 1 mark, rarely 1 mark, but most of the time 2 mark questions, sometimes even 3 marks we can expect upcoming this schedule, like this class, you understand. Okay. For prerequisite for understanding those algorithms or policies, now let's understand some basics. So what types of process times we use, understand, all of you clearly understand. The first one, arrival time of a process, arrival time, okay, observe all of you, arrival time. What is arrival time? The time at which process, please observe, the time at which process enter into ready queue. So ready queue, okay, ready queue. So that is a arrival time. The time at which, please suppose let's take time 0. The time at which process enter into ready queue is a arrival time of a process. It is clear all of you. Whenever you are going to use arrival time of a process, nothing but entering the time at which the process entered into ready queue is the arrival time of a process. Clear? Next, second term, schedule time, please observe, schedule time, okay, schedule time, please understand, all of you understand. Here is a ready queue, are you getting my point? Here is a ready queue, here is a running state, all of you please observe. Now see, now here is a new state, right, now the process we loaded from year to year, right, year to year we are loaded. This is what time at which the process loaded into this state is what? Arrival time. The time at which process is scheduled for execution, this is what ST means schedule time. So we are taking a process PCB from ready queue, remove PCB from ready queue and attach to the running state. The time at which you schedule means the time at which process exactly start execution from CPU, we call schedule time. I hope this is clear. Everyone please respond. Schedule time is clear, the time at which process starts executing the instruction or the time at which process will attach to the CPU state is a scheduled time. So, I will give example. Suppose morning 9 a.m. process has been entered into ready queue. 9 a.m. process has been entered into ready queue. So, 9 a.m. is arrival time, but CPU might be busy with other task. At 9:10 we have scheduled, we have observed CPU is ideal. So, at 9:10 we have attached to the CPU state. Now, at 9:10 process started executing. Now, 9:10 becomes a scheduled time of a process. I hope this is clear. Okay, two terms are over. Third one. So, arrival schedule, then bus time. We use the word, another one, bus time. BURS, bus time. Bus time also known to be service time. Bus time also known to be service time. Please observe. Now, here is a CPU state, right? CPU. Okay, CPU. Please observe CPU. Somewhere here IO also there, like understand. IO also there. Please observe. The amount of time this process PI spending on CPU as well as IO. Are you getting my point? Amount of time process is spending on CPU or and in IO. This is what simply bus time or service time. Is it clear? Let us take example. 9 a.m. we schedule. 9 a.m. started execution. It's running 9:30. So, 20 minutes has run. So, 9:30 till 20 minutes. 20 minutes might be spent on only CPU. Maybe 15 minutes spent on CPU. 5 minutes spent on IO. Whatever activities happen that. So, that total time we call bus time or service time. Now, this bus time or service time are two types. Okay, please observe. One is CPU bus time. Other is what? IO bus time. So, I hope you understand. CPU bus time is purely CPU time. The amount of time process spent on only CPU, that is CPU bus time. Getting my point? Amount of time which is spent on IO, that is IO bus time. Together we call bus time as service time. Correct? Now, some assumptions also we made while discussing the various decision policies. Sometimes we assume IO bus time is 0. So, when IO bus time is 0, the CPU bus time only will be there, that is equivalent to bus time only. Simply you can call CPU bus only bus time or CPU bus time. But when specifically you want to call CPU bus time, you have to call separate IO bus time also. The specifically you can also call, when one term is ignored, other time we have used, that simply we call bus time only. I hope this is also clear. Yes. Yes, okay. Is it clear? Bus time or service time, it can be CPU bus time, IO bus time. If I say only CPU bus time is there, process not required any IO activity. Right? Chalo, other term we will see. Fourth one. So, now first we have arrival time we have seen. Then second what we have observed? Schedule time we have seen. Then bus time also we have seen, CPU bus time, IO bus time. Yes, 3 terms clear all of you? Respond. 3 terms are clear, right? 3 terms are clear, right? Now, let us observe. Fourth one is, again I am taking the turnaround time. So, turnaround time. Okay. What I say turnaround time, nothing but total time. Total time to execute a process, including all. From beginning to ending, entire is a total time. So, let us understand clearly. Let us take process PI. PI is a process, all of you please observe. PI is a particular process. Now, PI is enter into system. Let us take, please observe all of you. So, now this is a transition, please observe. Okay, it is enter into where? Ready queue. Okay, we call arrival time. Are you getting my point? PI enter into ready queue time let us take 0 time. Where this process initially ready queue, right? It is initially ready queue. It is waiting or not? Tell me, it is waiting or not? Waiting. Let us take waiting time 1. I hope this is clear, all of you. I hope this is clear. Is it clear, all of you? Is it clear? So, ready queue initially it is waiting. After some time, after waiting, so it got a chance of execution, like it is executing CPU. Okay. So, what I said you, CPU, when you are process pending in a CPU, nothing, bus time we call. So, let us take this is a bus time, partial bus time B1 is there. Okay. Are you getting my point? So bus time we occur, CPU spend. After some time running process, please observe all of you. Running process, okay. Running process required IO activity. Assume that IO wait, okay, IO. The process went for IO. Process went for what? IO. That running process went for IO. Okay. IO bus time. This we call IO bus time. We call IO bus time. Right. After that, again it will come where process state transition diagram we have studied, right? Once IO activity we have over, whenever running process required IO activity, it will move from running to block state. Once IO activity over, from block state it will come back to ready queue. So it will come to ready queue here. It will come to ready queue. Getting my point? Ready queue. The process coming into where? Ready queue. So immediately process may not get chance, right? It will wait. So let's take waiting time 2. Waiting time 2. After some time, process got a chance. It is enter into CPU state. It enter into CPU state. Now bus time. Bus time what? What is the bus time? 3. Bus time 2. Yes or no? Bus time 1, bus time 2. Suppose the preemption is occurred. Running process preemption occurred. So this again come back to ready queue, right? Ready queue. So waiting time. So waiting time. So waiting time. Let's take 3. Waiting time 1, waiting time 2, waiting time 3. Clear all of you? It is clear. Is it clear all of you? Now after some time we got a chance CPU. It has run. Okay, it is run. So bus time of 3 assumption and completed, execution over. Execution is over, arrival time. Now what is the turnaround time? Can you tell me? So this is a complete life cycle of one particular process. I have shown you all the possibilities can happen. So during execution mostly, like all the 3 states majorly covered. Ready, running, block, again ready, running, ready, like this, understand. Right. Can you now define what is a turnaround time? So total time is a turnaround time only or not? Yes or no? From here to here, from here to here. So this is entire time is what? Turnaround time only or not? How to take now turnaround time? Completion time minus arrival time. Yes or no? Completion time minus arrival time. Am I right? All of you, am I right here? Everyone respond. Respond. Yes, completion time minus arrival time. So this is what turnaround time. Okay, now so this term is clear. Now fifth one, waiting time. Waiting time. Yeah, can you define waiting time? How to write waiting time? So from this one, from this at least you tell me waiting time. How to get the waiting time? So you see, here is a waiting time, right? Here is a waiting time. Here also waiting time. Here also waiting time, right? Waiting time. How to get the waiting time? How to get the waiting time? Give expression at least. How to get the waiting time of a process? You want to say summation of this all weights, waiting time 1 plus waiting time 2 plus waiting time 3 plus waiting time 4, like this you want to take. But sometime process may repeats ready to running state, running to ready state. Many times process may suspend, may get preemption. Are you getting my point? It is not necessary one time only preemption can happen. Process preemption can happen in number of times. Now how to take the expression for turnaround time minus bus time? Very good point you observe. So now suppose here is waiting time nothing but turnaround time TAT if I take minus bus time. Simply what is the bus time? Total time, right? Yes, exactly you said CPU burst. Okay, CPU bus time plus what? IO bus time. Suppose some situation, suppose example, assumption, suppose understand IO bus time suppose not there, 0 assumption. Now simply what I can say, turnaround time minus bus time, which is CPU bus time by default. So this is going to be waiting time of a process. When IO bus time is considered, both you remove. CPU burst, IO burst you remove, total time pay, then you will get this is the waiting time of a process. Suppose IO bus time is not there, suppose not considered, suppose you consider 0, if neglected, then simply what waiting time of a process would be, waiting time of process would be turnaround time minus bus time. I hope this is clear. Good point, good point, good point, Bob. Okay. So now, so mostly we have understand what is the turnaround time, what is the waiting time, what is the bus times, arrival time, completion time. So we forgot like sixth one, completion time. Completion time. What is the completion time? Very simple. Completion time nothing but the time at which process is completed. Process is completed. We call completion time of a process. So whenever the process is completed, eventually it will move to termination state, right? From running state it will move to termination state, right? Time. So that time we call completion time. So anyway, I use the word here, right? Here also you know, here is completion. Arrival, completion, turnaround time, waiting time, bus times, IO bus, those all the things we have done, correct? So quickly some notations I will give it, some process times and notations. So notations for process times, notations for process times. Okay, all of you. Let Pi is a process. Pi is a process. Let me take I is defining from 1 to n. Okay, n process are there. Observe all of you. I am defining 1 to n. Is a Pi is a process. All of you observe. Okay. First one. Please observe. Arrival time. Arrival time. I am defining. Arrival time of a process Pi. I will define like this. Arrival time of a process Pi like this. Is it clear, all of you? So short form I am using arrival time AT process Pi. Okay, clear. The second one, schedule time. So schedule time of process Pi, simply, otherwise you understand like defining me, so better I will define like this, not this form. Arrival time of process Pi, I'll make it like this. Arrival time AT of process Pi. Okay. So this I am taking AI, simply AI. What is AI? What is AI? Arrival time of a process, simply you understand. Schedule time. So schedule time ST of process Pi, I'll be making SI. If I write SI, what is SI? Schedule time, you understand. The third one. So third one, completion time. Completion time. So C T of process Pi, I am writing like this, CI. CI indication, what is CI? Completion time of process Pi. What is AI? Arrival time of process, schedule time of a process Pi. Clear? The fourth one, okay. This AI, CI over, right? Next fourth one I am taking bus time. Okay, bus time. So BI, like now I am taking BT of process Pi, I am taking as a XI. Please observe XI. So now in this case, please observe XI means what? So IO is no IO bus timer. So bus time is no IO bus time. Bus time is not there, simply I am taking. Okay, next. Here only, otherwise you understand only CP bus time, you make it otherwise only CP bus time. Only CPU bus time. Okay. Next one I am taking bus time. Okay, bus time of a process Pi. Which process? Like no YI. Let me take YI. What is the YI here? IO bus time. When you consider IO bus time. Otherwise you write IO bus time, CP bus time also, okay, no problem. XI is the CP bus time, simply YI is the IO bus time. Assumption. Clear? All of you. Fifth one. So, fifth one. So, arrival time, schedule time, completion over, then bus times also over. So, can we take turnaround time? Turnaround time. How to take the turnaround time? Turnaround time, yes, all of you. So, let me take TAT of a process PI. Process PI. How to define process PI turnaround time? Turnaround time, how to define? Completion minus arrival, right? CI minus AI. Can I write it or not? CI minus AI, all of you. Can I write it? All of you. So, this simply if you want to write it, okay. So, TAT of process PI equal to CI minus AI. Just simple form also you can write like this. Okay. Clear? So, note of it. I hope you are writing. I hope you are writing. Okay. Next. Sixth one. I will be asking what is the average turnaround time? Tell me, ma. Average turnaround time of a process. How to get the average turnaround time of a process? The particular process average time we got here. Average turnaround time. Average turnaround time. So, totally how many processes I assume? N process, like summation. Yeah, summation. Okay. I equal to 1 to N process. Okay. Completion I minus AI. Is it not? Divided by how many process? N process. Yes or no, all of you? So, this is what average turnaround time of a process. Any doubt? Any doubt here? So, seventh one. I will ask what is the waiting time of a process? Waiting time. Waiting time of a process, double T of process PI. How we can define it? How to define this one? Turnaround time minus turnaround time process, TAT of ith process minus bus time. Bus time is what? XI. Okay. Simply you can make it that is, so that is waiting time of a process PI equal to turnaround time of ith process minus XI. Okay. So, this in this case, what is the point here? No, considering what? What is the consideration? IO bus time equal to 0, this expression. When considering IO bus time 0, simply turnaround time and bus time I can remove, CPU bus time I am removing. Now, another formula, waiting time of a process PI equal to turnaround time of ith process minus XI plus YI. I hope this is clear. XI plus YI. Okay. When this one IO bus time, okay, CPU bus time not equal to 0, IO bus time also not equal to 0, minimum is there. Am I right? This is clear? This is clear, all of you? So, do not remember like a formula, just do the observation, because if you start remembering, one day you will forget. Do not remember, because understand the meaning. Total time pay, you remove just waiting time, that's it. Sorry, bus times you remove, remaining waiting time only. We need waiting time, right? Total time I know. Remove this usage time, remaining is a waiting time only. So, that way you start understanding, ma. Clear, ma? Suppose now you put, now seventh one I will ask, what is the average waiting time of a process? What is average waiting time process? 1 by N summation I equal to 0 to N turnaround time of ith process minus bus time of ith process. So, this all make it mostly because mostly when I am considering what CPU bus IO bus time is 0. Very simple, IO bus time is also there, you add X plus Y, that is it. By default you can take this one, because for problem solving many at a time we take IO bus time is negligible, 0 only. CPU bus time consideration I will do, total turnaround minus bus time I will remove it. Yes, is it clear? Is it clear? Average turnaround time, average waiting time, can you able to understand or not? Average turnaround time, average waiting time. Because in the gate question, many a times I have seen, if the question is framed from a CPU scheduling algorithms, many times happened. They asked particularly what is average waiting time, what is average turnaround time, or simply what is turnaround time of this process. Simply find out the waiting time particular process. They only this only terms only ask many a times. That's the reason just little we are observing properly these points. Okay. Okay, it is clear. Waiting time is clear, all of you. Then another time I am going to use, another term is schedule length. Schedule length L, okay, is a time only, schedule length also time, okay. So schedule length L need to be find out. They ask sometimes schedule length also. What is this time? So this is measured in time only, okay. Length, what is the length? Let's take an example, all of you. Let n processes are there, okay, n processes from like suppose I is a process pi. If I take 1 to n is there, like I is a process pi, okay. Now also if I take n equal to 3 process, if I take n equal to 3 process, all of you observe. So process P1, process P2 and process P3, okay. If these 3 processes are suppose in a ready queue, how many are there? 3 processes are there. Now scheduler will pick one process among 3 and assign to CPU. Now scheduler can pick process P1 or P2 or P3. Now I will ask how many ways this process can be scheduled. Can you tell me how many ways? I am asking simply how many ways this n or 3 process can be scheduled. Processes can be. So one of the gate question also they ask here. How many ways we can schedule this process? Respond. How many ways process can be scheduled? If I take 3 process, so now that you understand, that you have to understand all of you. Okay. So this already we have solved. These questions already we have solved. You do not worry. That problems already we have solved in the last class. You see. Okay. So means process P1 first, then process P2, then process P3. One order I can schedule it. First P1 execute, then P2, then P3. Or you can start P2, then P1, then P3. Okay. Or you can start P3 first, P1, then P2 like this. Tell me how many ways we can schedule it. Respond. How many ways we can schedule it? Is it not 6 ways? 6 ways. So this is nothing but what? 3 process or 3 factorial ways we can schedule, right? If 3, suppose if I take n process, if I take n process, n factorial ways, yes or no? If I take 3 process, 3 factorial ways, n factorial ways we can schedule it. Yes, you are right, n factorial ways we can do it. Now schedule length here picture comes, observe. What is this schedule length L? No, schedule length L. Schedule length L is talking about here. Okay. So here I am taking 3 process. I have taken 3 process. Total time. Okay. Total time. Time is required. Okay. Required to complete a schedule of 3 process here. Now taken 3 process, right? P1, P2, right? I have taken 3 processes. How much time required to complete all 3 processes? The schedule time. Are you getting my point? Other way I will tell you. Suppose 3 processes are scheduled at 9 o'clock, morning 9 a.m. schedule. But all 3 processes completed at 12 o'clock. They have taken how much time? 3 hours time taken, 9 to 12. Right? 3 processes are scheduled 9 o'clock. They have completed at 12 o'clock. Any order I schedule, they complete 12 only. Now 3 hours I have taken a time to complete the 3 process. Now schedule length becomes 3 hours here. Now give a expression, mathematical expression to get this total time. Can you tell me, all of you? Any order or process may comes at different times also. It's not necessary all 3 comes at 9 o'clock. Maybe out of 3 only one process came 9 o'clock, remaining came middle. but all execution started 9 o'clock, one of the process, and 12 o'clock completed another process like this. All process completed. They have taken 3 hours time. I given value. Now tell me the expression to get the 3 hours here. I hope you understand. I hope you understand. Let's take suppose here is a process P1, process P2, process any order I can shed. Suppose it taken 3 minutes time required, is 2 minutes time, 5 units required. But total time how much required? 3 plus 2 plus 5. So generally 10 units, right? 10 units. But you know 10 units not as an answer. 10 units not an answer. Answer means 10 units may comes, like my point is that how to take up, find out the schedule length, how much time required to complete this process. Started at what time? 9 o'clock and with 12 o'clock like this. How to get this time? First I schedule maybe P1, then P2 or P3, or P3 first, P2 plus, then P3 next like this. Whatever order I schedule it, now tell me how much time required to complete this. How to get the formula for that? Respond. Suppose, let's understand, like 9 o'clock, among 3 only one process comes, I scheduled it. I started exam. You may be running it till 9:30. So 9:20 one other process comes, that also scheduled at 9:30. It went to 11 o'clock or something. 11 o'clock another process schedule, it complete 12 o'clock. Right? So another last process may come, so 11:30, like 10:30 we schedule at 11 o'clock. So 11 o'clock, 12 o'clock it run. So total process completed 9 to 12 over. Now how to capture this time is the question. How to capture? Any idea? Respond ma. Yes, Saki. How to get the schedule length? Schedule length L. Schedule length L. How to get this time? You understand now. So last process completion time minus starting of first process arrival time. Good, very good point, appreciable. Yes, that is right. Last process completion. Last process completion means, suppose you understand, here I am going to draw this one. Okay. So process P2, suppose schedule assumption. Start at 0, process P2 record 2 instead of 02 will run. Then suppose if I schedule the process P1, it is taking 3. 2 plus 3 how much? 5. Then I schedule the process P3. 5 plus 5 how much? 10. Okay, 10 is the time, completion time. 0 started, 10 completed. This would be one order. Even other order would be also there. Now you have to take last process completion and minimum arrival. So what should I do? Last process completion nothing but, please observe, last process completion nothing but maximum, please observe, maximum completion time of ith process. It could be any process, right? It could be 1, 2, 3, any process, whoever completed last, completion time of last process, minus whoever comes first, minimum of arrival time, ith process. So this is the expression for schedule length, my important things. Okay. Right? So now see, please, question comes, no? N process, see, here is suppose 3 process. 3 process completed time what? 10, right? Like I am marking in terms of N. N process completed schedule length L or not? L only, schedule length L. What is schedule length? Total time required to complete all the process. Whatever the process schedule comes. Schedule comes 10 process completion time. 100 process comes, 100 process completion time is the schedule length now. I am generalizing N process taken to complete how much time? L. First question, one process to complete how much time required? Tell me. To complete N process, L time is required. To complete one process, to complete, so I'll be marking like, no, here I should take it like this I have to take. To complete one process, how much time required? Sorry sir, now I written, sorry sir, I'll take. L time required, I'm asking like this. Like I'm asking like this, no? How many process I can complete, how many process I can complete with 1 unit of time? 1 unit of time. I'm taking 1 unit of time. L units or L time is taken to complete. So if I give 1 unit of time, how many process will complete? That is nothing but what? 1 into N by L, right? This is only throughput of a system. So throughput. So in English, what is the like verbal statement I given for throughput? Verbal statement is number of process completed per unit of time, right? You see, number of process completed per unit of time. Per unit time is what? L. Unit time is what? L. Unit time is what? L. So what I am trying to say is, suppose completely if I removed, where I am just reading. So the term number schedule length is what? Schedule length is 8, right? 9. So ninth one. So ninth one, I am asking you throughput. I am asking you throughput. Find the throughput. So throughput definition is number of process n completed per unit time is L. L is what? Schedule length. This you to understand. I hope you got also. Okay. Is it clear? Is it clear finding the throughput? Everyone? Everyone respond. See, time, number of process n, total number of process n, and taken time what? L. N by L is a throughput. That's it. N by L is a throughput. Respond. Is it clear? So now various times you see, now arrival time I know, schedule time I know, completion time I know, bus time, IO bus time, CP bus time I know, turnaround time I know, waiting times we got, response time also we got, response time also we understand, schedule time also we understand, throughput also we understand. Total nine parameters we observed. So these basics are enough to understand the various decision making policies, that's CPU scheduling algorithms. Okay. So now I will be stopping the session. So upcoming schedule will start first come first serve scheduling algorithm, and the various gate questions also will solving ma. So try to, like, whenever you get a notification, try to join and learn the things ma. Thank you so much. So just let me know if you have any doubts so that I can discuss for a few more minutes. Otherwise I can stop the session. We'll continue in the next class. Yes, Saki. Okay, ma. I'll be stopping the session then.